All right, let's kind of go over some of the problems in 1.7. Um, the first four, you're going to do these all the same way. You want to graph each function using a graphing calculator. I'm using Desmos, and apply the horizontal line test to determine whether its inverse function exists. If it passes the horizontal line test, the answer is yes. If it doesn't, the answer is no. So on this first one, 3 times the absolute value of x plus 2, I have that V-shaped graph. I drew a horizontal line, and right there, it touches twice, so no. It doesn't have an inverse function. There's an inverse equation, but it's not a function. Okay, so you do the same thing on problems 1 through 4, graph them on Desmos, and then see if it passes the horizontal line test. All right. On 5 through 8, you want to determine whether f has an inverse function. If it does, find the inverse function and state any restrictions to its domain. So I'm just going to graph that first. Oops. To see what that looks like. So on this one, this is what number 5 looks like. And again, I could make a t-table for it, but why when I have a graphing application? So that would pass the horizontal line test. So I need to find the inverse. To find the inverse, you switch the x's and your y's, and remember f of x is the same thing as y. So I'm going to have x equals the cube root of y minus 1. And I have to solve for my new y. So to get rid of a cube root, you do the inverse or the opposite and cube it. So I'm going to have x cubed equals y minus 1. Add 1 to both sides, and I'm going to get x cubed plus 1 equals y. And then I need to show that it is an inverse. So I'm going to write it back in function notation. And that little 1, the superscript 1, shows that it's inverse. So the inverse function of x is x cubed plus 1. And you do the same thing for 6, 7, and 8. Switch your x and y's around, and then solve for your new y. All right. On this one, on 9 and 10, you are going to have to show that they are inverse functions of each other. And that's where you have to use the composite functions and show that each composite function equals x. So I have to do f of g of x and g of f of x. So on this one, I plug the g function into the f function. So 2x plus 3, take out the x and put in x minus 3 over 2. On this one, I'm going to plug the f function into my g function. So I had x minus 3 over 2. Take out this x, put in 2x plus 3. Now you just need to simplify them. Put that over 1. The 2's cancel. You get x minus 3 plus 3, which is just x. Here, 3 and negative 3 cancel, and you end up with 2x over 2, which is just x. So that works, and that works. I've just shown algebraically that they are inverses of each other. All right, on here, We have to use the graph of f of x to graph the inverse. Remember, if something is an inverse, it's going to be a reflection over the line y equals x. Let's go ahead and draw that in. So that would be a reflection. So all I'm going to do is just sketch a reflection of that, where it flips it over. Oops, make that a solid line. Let's do it in red. Okay, so right here, I'm just going to do that little part right there. Then it comes up. And that's what its reflection would be. You just have to visualize what it would look like if you folded that sheet of paper over the dotted line. All right, good luck.